How do control systems handle external disturbances? Imagine trying to keep a boat steady in choppy waters. External disturbances like waves or wind try to throw you off course. Control systems work similarly to keep things stable. They use different methods to handle these outside influences and keep the system running smoothly. One common way is through feedback control. This method constantly checks the system's output with sensors. If the output deviates because of a disturbance, the control system adjusts its input to bring things back to normal. For example, in a temperature control system, if the room gets colder due to outside weather, sensors detect this change. The system then increases the heater power to restore the desired temperature. Feedback control is very effective because it reacts to changes as they happen. The system compares the current output with the target value and makes corrections. This process is like steering a bicycle by constantly adjusting the handlebars to stay balanced. The mathematical part involves calculating the difference between the desired and actual output and using that to decide how much to adjust. But sometimes, it's better to anticipate disturbances before they affect the system. That's where feedforward control comes in. It measures or estimates disturbances directly and adjusts the control input beforehand. For example, if a temperature sensor detects a sudden cold draft, the system can increase heating even before the temperature drops. This proactive approach helps prevent deviations rather than just fixing them after they happen. Advanced control methods also include robust control design. These techniques are built to handle uncertainties and unpredictable disturbances. They aim to keep the system stable even when the disturbances are strong or the system model isn't perfect. For instance, in electrical systems like voltage regulators, robust control makes sure the output voltage stays steady despite fluctuating input power or load changes. In electric motor speed controllers, feedback adjusts the power input to maintain a constant speed when external loads change. Temperature control systems relying on sensors and feedback loops to keep the temperature steady, even if environmental conditions shift. Some control systems even use disturbance decoupling techniques, which dynamically adjust control actions to isolate the effect of disturbances, making the system more reliable. In summary, control systems handle external disturbances by constantly sensing the output, comparing it to the desired value, and adjusting inputs through feedback and feedforward methods. Robust control techniques further improve their ability to stay stable and perform well despite unpredictable influences. This way, electrical systems can operate reliably, even in the face of outside challenges.